In this lecture, you will learn how to measure temperature and humidity. To do this, we'll use a sensor from the DHT family of temperature and humidity sensors. The most common DHT sensors are the DHT11 and 22. The DHT22 is double the price of the DHT11, while still only about $10 on eBay, but has better accuracy. Electrically, they are exactly the same, so you could swap them in and out of your circuits at any time. You can find DHT11s on eBay for less than $2. There are 4 pins in the sensor's package, but only 3 are actually used. Looking at the device from the front, going from left to right, pin 1 is for 5-volt power, pin 2 is for data, pin 3 is not used, and pin 4 is ground. Inside, this sensor is fairly sophisticated and contains hardware that does a lot of the work that otherwise we would have to do in our Arduino sketch. As a result, as you'll see in a minute, all we have to do is take a reading. There is no need for any conversion calculations or any other hardware at all. The DHT11 and 22 sensors within the plastic case contain a capacitive humidity sensor, a thermistor, and a chip that does analog to digital conversion. Capacitive humidity sensors are robust solutions for measuring humidity if our application is okay with the relatively low accuracy of this device. Both DHT11 and 22 have a humidity accuracy of around 5% and are calibrated in the factory. In a capacitive humidity sensor, a polymer or metal oxide material is exposed to the environment and its dielectric properties change as the humidity changes. A thermistor is a resistor in which the resistance changes as the temperature changes. In the DHT11 and 22, the readings in temperature are fairly accurate at around 0.5% accuracy. Time to put the demo circuit together. We will need the Arduino, 3 jumper wires, a DHT11 or 22, and a 10 kilo ohm resistor. The resistor is used as a pull-up and it protects the Arduino or whatever logic device the resistor is connected to in case we either remove the sensor or the sensor malfunctions. The Arduino's input sockets have built-in pull-up resistors, but they are much smaller and it's a good idea to provide our own. Here's a demo of the circuit being assembled. We'll start by plugging the device into the breadboard. Just be wary of the pins and where each one will go so that you'll be able to plug the jumper cables at the correct place later on. Start with connecting the power that goes to the 5 volts on the Arduino from pin 1 of the device, and we'll ground it. It's pin number 4 on the device to ground on the Arduino. Next, add the pull-up resistor between pins 1 and 2 on the device. And finally, the data cable, the green cable, to the Arduino. Let's connect the Arduino to the computer via the USB cable, upload the sketch, and bring up the monitor so we can see the output of the device. And here's the monitor. You can see that it's outputting data. With the demo circuit assembled, let's now turn to the Arduino sketch that will drive it. Notice that there is an inclusion of the dht.h library in the first line. This library makes it easy to communicate with the DHT device. You will need to download it and make it available to your sketch. Get it from Adafruit's GitHub account. The address is provided. Let's go through the sketch and have a look at how it works. First, we include the DHT library by using the include instruction. We define that the data pin for the DHT library will be 2 and that the type of device is DHT22. We'll then initialize the library. We set up our communications between the Arduino and the computer and send out a hello message. We then start the DHT device by saying dht.begin. Let's go in the loop function now. We take measurements for humidity and temperature using floating point variables h and t. Once we take a measurement, before we print any values out, we check to make sure that we have actual numbers. So isNaN means is not a number. If isNaN returns true, then we know that the device did not return proper values, so we're not going to print them out. Instead, we're just going to let the user know that we have failed to take a reading from the device. Otherwise, we'll go ahead and print out the humidity and the temperature readings using the serial.print commands. And we only want to take a measurement every about half a second, as the DHT devices are not very fast anyway. And that is how you connect and use the DHT22 or DHT11 sensor with the Arduino. Please attempt the quiz questions before moving on to the next lecture.